Hey guys, in this video we'll see how to reach an Oracle explain plan. For this I have picked three tables. The first table is student table, and the second table is subject, and the third table is marks. So I am interested in finding out student name, which is in table student, and subject name, which is in second table subject, and the third column I am interested in is marks from the marks table. As you can see, this is a relational database. Oracle is a relational database, so I have designed my tables accordingly. So all these tables are related via subject code, and student and marks table is related by student ID and subject code. So to find out the student name, subject name and marks, I have to write a query, so which I have already written here. So I'll show you how to run that. So I get student name, subject name and the marks. Okay, so now we'll see what is the explain plan for this. So to explain plan for, you should only pick the select query which you are interested. And you can read the explain plan by querying select star from table dbms underscore explan dot display. Okay, so you have got a select statement, and then there is a hash join and another hash join. So there is table access full on student and marks and table access full on subject. First hash join is on student and marks, and second hash join is on this hash join and the full table access on subject. And after doing these two joins, we get the final output. Okay, so which is student name, subject name and marks. Okay, so we will save this explain plan, and there is one more change we will do. We will create index on all these three tables. Okay, and run the explain plan again. So let me clear the screen. Headlines, I'm doing some formatting. Page size 500. Explain plan for. Now I have created index, so my explain plan is going to change. So we'll query that explain plan. Select star from table dbms underscore explan dot display. So we get new explain plan. Okay, so now we have two explain plan, one with index on the three tables and one without index, that is full of table access full. Now there is a mix of table access full and table access by index row ID. So I'll show you how to read the explain plan. So let me pull up a pinch diagram, so there I can explain you with the help of tree and branches. So I'll show you how to read the explain plan. So for the first case, we don't have any indexes on these three tables, student, marks and subject, so everything is full table scan. So as you can see, I have drawn a tree diagram based on this tabular representation of the explain plan. So you should see the ID column, it is 0 to 5. So this will be the nodes. So 0 is the first node and 1 is second node, and After 1 there is some difference. Okay, there is one branch 2 and there is also one more branch 5. So these are two branches because they are on the same line. Okay, so I have drawn two branches after node 1, number 2 and number 5. And after node 2, again you can see there are two branches, branch 3 and 4. These are also in same line, so I have drawn them on the same line. Now to read this explained plan, this is a tree diagram. So to read this explained plan, you have to go from bottom left. Read from bottom left and traverse up to the top. So this is how Oracle internally does. So it identifies this tree diagram, means internally this is how it works. So it goes to number 3 and says that it has to access student table. This is a full table access, so it gets name, student ID and subject code, and then it goes to marks table, which is at number 4. This is also a full table scan. Okay, as you can see, it has these two data in two buffers. Now what it does is it does a hash join on these two data sets. This is a hash join. In this hash join there are two conditions which we have written in the query. One is a dot student id equal to c dot student id and a dot subject code equal to c dot subject code. Okay, so a dot student id and c dot student id, you can see these are matching, this column, and then subject code is also matching. So if these two are matching, then we have the first set, that is name and marks of a select query. Okay, so this was our select query, student name, subject name, marks. So we got student name and marks from joining table 3 and 4, that is student and marks. So now we have name and then we have marks. So we need to know what is the subject name. So next step is go to subject table to find the subject name. So to do this, Oracle does a full table scan of subject table, and it has a lot of rows, around 6 rows, and this data set for the hash join has 3 rows. Okay, so next step is, we are here, we have this query, this data set is 0.2 and this data set is 0.5. So after joining 2 and 5, we get this data set here, which is number 1. So this data set is compared with subject table. So how does it do? So that is done by p dot subject code is equal to c dot subject code. Okay, so this is b dot subject code and c dot, this is c, so this is b. So b dot subject code equal to c dot subject code results in 47 and 55, which is physics, chemistry and French. Okay, so we get physics and French and chemistry, and the names are Tom, Harry and Mary. Okay, the marks are 90, 85 and 75. Okay, so this table 2 and 5 are hash join is being done at 1 and the resulting data set is sent to 0, which is our select query. So we have name and marks here, and the subject name is being taken from joining subject and marks table with the help of subject code. So 40, 55 and 7 we get the corresponding subject name. Okay, so this is the output. So let me show you again. You can see b dot subject code equal to c dot subject code. We get student name, subject name and marks. Okay, this is how you should read the explain plan. Now this is part 1 of the video. So in the part 2 we'll see how indexing will help this explain plan. Okay, so now let's look at plan 2, because in plan 1 I showed you which was a full table scan and how to read an explain plan. Now I made an explain plan little more complicated, because now our plan contains couple of more or 3 index scan. There is 2 index range scan and then table access by index row ID. So I'll show you how to read this explain plan. So I've drawn a tree diagram of this explain plan. As you can see, there are nodes 0, 1, 2, and at node 2, that is here, there are 3 branches, 2 branches, branch 3 and branch 7. So I've drawn branch 3 here and branch 7 here, both are at the same level. And again this branch 3 contains again 2 branches, branch 4 and 5, they are also at the 2 same levels, so 4 and 5. And again branch 5 has one more sub branch, 6. Okay, so to read the explain plan we have to traverse from bottom left, that is 4. So the 4 is ID 4 is table access full on marks table. So what Oracle does is it does a full table scan on marks table. So we have student ID, subject code and marks. Okay, and since 4 and 5 at the same level, you can see at level 5 what is happening is there is table access by index row ID. So this for table access by index row ID, it needs an index. So that index is subject IDX. So this is a subject table. So we have created an index on this subject, marks and student table. One of the index is subject IDX. So this subject IDX contains subject code, say 40 for example, and then it also contains row ID of the row which contains this subject code. It means since this is a subject table, this also has an internal column called as row ID, which is having some numbers. So let me write it here, 1, 2, 3, 4, 5 and 6. So when you create an index on subject table, it stores all the values in the index, and also it stores the row ID of the entire row which contains subject code 40. Okay, so for example, if there is an index on subject code, so there is a value 40, and also there is a row information which can be accessed by row ID. So that row ID is stored here, okay, which is row ID 1. So if you access this table directly, that is subject, you can access subject name. There is one more way, that is you can first access subject code via an index and then get the row ID of this particular row, that is 1, and through this access the subject name. So this is very quick for big tables. So that's why you can see here first the subject IDX is being used, which contains the subject code, and then since we are interested in subject name, it is accessing the subject table with the help of row ID. Okay, so now at point 5 we have full table or table access of subject with the help of index row ID, and 4 was marks. Okay, so these two are joined, so that join condition is at the point 3. Okay, that is a nested loop. So what it will do, it will compare these two common values. So the common values are 40 and 7 and 55. We get subject name, physics, chemistry and French, and corresponding marks 90, 85 and 75. Okay, now we have subject name and then marks. Okay, this is physics, chemistry and French. The marks are it is physics, French and chemistry, pardon me, French and chemistry. So the marks is physics is subject code 40, the marks is 90, French is 7, which is 85 and 75. So we got subject name and marks, and one more column is needed, which is student name. So but we are at here point 3. There is a nested loops on subject and marks table. So note that the way Oracle is accessing this joins is different when there is index and without index, because without index, first there was a join on student and marks table. This was the first join, but with the index there is join on marks and subject table. That is the first. So once you have the join of these two tables, it is getting joined with one index range scan on student IDX. So student IDX is again an index on subject code. Okay, so as you can see here, there is a where clause a subject code equal to c subject code. So this a subject code is being accessed with the help of student IDX index, so which is a good thing because we are not accessing an entire row, so no need to access name and student ID if we are only comparing the subject code, right? So a subject code equal to c subject code. Okay, so this is the marks table. So a subject code equal to c subject code. So note that, so that's why the index is being used. So instead of comparing both table and table, we have, since we have index on subject code on all three tables, only this is getting compared. That is a subject code equal to c subject code. So that is the condition which we have in the select query. So that is being accessed at point 3 and 7. So at 2 we have the data which is joined by point 3 and point 7. Okay, so like I said, 3 and 7 was having data related to subject name, subject code and marks. Okay, and we have at point 7 the index range scan of student IDX. So a subject code and c subject code is being done. So that data is being sent to point 2. Okay, now we still need the student name, right? But we have not accessed the student table yet. There was only operation on index table, that is student IDX. So this student name is what we are interested in the final select. So that data is accessed with the help of index, that is table accessed by index row ID. So at point 1 we get all the student name with the help of row ID. Like I said, student IDX will have two columns. One is subject code and row ID information of student table. So it has subject code 40, which means it will know that it is row ID 1. So with the help of row ID, it can see what is the corresponding name. So that name comes here. Similarly, Harry and then Mary. So as you can see, this is a explain plan with the help of index. Now next thing, since you know by now that how to read the explain plan and how index table access by index row ID will help us the performance, because instead of comparing table by table, we are just comparing the each column only. Okay, so this column data is stored in index, and the comparison is very fast, and also the number of buffer gets will be less with the explain plan, this 1188886298 plan hash value. Okay, so what Oracle does is, whenever you access a table, it will see if the table information is there in the memory, or else it will go to data files to get the information. So everything will have some cost and CPU. So the number of reads will be more in case of full table scan. With the index, the number of IOs or buffer gets will be less. So I'll show you how to see this in the Oracle database. So let me open the command prompt. So we saw two explain plans. There I told you how the second plan with the help of index helped SQL performance, because we were not comparing table and table, we were just using the index, and with the help of index we were accessing the table with the help of row ID. So you can also check the performance of SQL with the help of this query. We can query $SQL. So this is very important. So first let us get the SQL ID. Looks like there is no information about the SQL. So to do that, we will run the select query again. Okay, so after this we know the SQL statement. So what we'll do, we'll get the SQL ID. Okay, so the SQL ID is 4AFFH4Y. So this is the SQL ID. So we will query again the plan hash value, the buffer gets, and what is the CPU taken to execute this query. So what is the buffer gets value? So let me run the query. So as you can see, the buffer gets is 40 and CPU time is 2145. Now what we'll do is, we will create an index on this table and see what is the performance like. Okay, so I created the query and then I'll run the query again. Created the index and I run the query. Now this query will use the index. Let's see what is the performance of this query now. So as you can see, this is the plan hash value which we saw now in the second plan. The buffer gets value is 15 and CPU time is 1544. So this is with index, the buffer gets is 15, whereas without index the number of buffer gets is 40 and CPU time is 2145. So a good query uses less buffer gets and less CPU time. Okay, so what we studied now is, if we create index on appropriate columns, the SQL performance can be improved. Okay, so see, the number of elapsed time also decreases. So any OLTP applications should have indexes on the table, because that will improve the performance. And for large number of transactions, the buffer gets and CPU time and elapsed time should be less. Okay, you can, I think, add one more column here, elapsed time from Vito SQL, where SQL ID is this. You can see the elapsed time is 2236. So similarly you can do without that. Okay, so this is a good lecture. We studied how to read the explain plan and how to see performance improvement with the help of explain plan itself. Like, I showed you how to read the explain plan, and I graphically showed you how internally Oracle accesses the joins. So we also saw how the performance improvement with the help of VDOLA SQL table. So all in all, we learned many things in this video. So we'll be making more Oracle lectures in the coming video. So if you like this video, please hit like and subscribe. There will be more videos coming soon on SQL performance tuning and Oracle database tuning. Okay. Also, if you want us to make any particular lecture, please comment. Thank you.